Let's start solving this problem by drawing the equivalent circuit. The three capacitors are in series, so we find their equivalent value using the reciprocal rule. Calculating to find the equivalent capacitance is 4.62 picofarads, pico being 10 to the minus 12. When we combine this with the resistance of 25 ohms, we can calculate tau, the RC time constant for this circuit. That works out to 1.15 times 10 to the minus 10 seconds. This problem asks us about the energy stored in the capacitors. So let's write down the energy stored at time 0 when they're fully charged. It's 1/2 CV squared, or using the definition of capacitance, we can eliminate the voltage V to write this as 1/2 the square of the charge at time 0 divided by the capacitance C. We're asked to find the time when the capacitors have lost 80% of this charge. So let's write the energy stored at some later time t. It's 1/2 the square of the charge at some later time divided by the capacitance C. We know the charge on the capacitors decreases exponentially according to this expression. So after substituting that, we can make this value equal 20%, what's left after losing 80% of the initial value. And now if we look at this last equality, cancel all the common terms, we find that the time for this to be true is met by this expression, e to the minus 2t over tau equals 0.20. It's convenient to write that as 1/5, so that when we take the natural log of both sides to eliminate the exponential and use the negative sign to invert the argument, we get this expression, which can be solved for the time t. Now we substitute values and find that 80% of the initial stored energy is lost in a time that's less than one time constant and given by this value.